when you study probability at some point, I guess it's useful to know probability odds. So probability is typically given in terms of maybe a fraction or a percent or a decimal, and it relates back to some kind of an event. So let's say event A, and that particular event can happen with some probability that's given. Now, when you're reading, sometimes you'll find that, in particular in sports actually, when betting lines are set, you might talk about odds. So in this video, I just want to go over that concept. It's not a very difficult concept. Once you understand probability, it's easy to go back and forth in between probability itself and then odds, which really just compare the probability of an event happening to the probability of the event not happening. All right. So on the screen here, I've mentioned that let's assume that we have some particular event A. And you can imagine that event A, let's say if it was sports, maybe that event A is a runner winning the track and field gold medal, okay, for example. So what would be the odds of that? Now, for that event A, you will have a probability of that event. So probability probably would be very low of even the top sprinter winning, because anything can happen, from injuries, having a bad race, getting disqualified. So you can find the probability for that particular event, and it most likely will be a subjective probability in some case if you're talking about sports, because it certainly won't be theoretical. In sports, there's so many unknowns that can happen that we typically utilize subjective probabilities. Now, the complement of that event would be that that runner would not win the gold medal, and then we say that the probability, so this is the second thing here that you see, okay, so probability of not the event happening, or sometimes it is written as probability of a prime, okay, we call that little prime up at the top. So that is the probability of the event not happening. And in odds, what we do is we take the probability of the event and we compare it to the probability of not that event. And so this, what you see right here, kind of the colon, so we typically will read that 2. So probability of A to probability of not A. But oftentimes you can also express this as just simply a fraction, where the probability of A is on top, and then you have the complement at the bottom. And don't forget that in all probabilities, right, if it's possible, you would have the total number of the event happening, if this was kind of theoretical in a sense, divided by the total number of the entire sample space. So S would be the entire sample space. Let me show this to you through an example, and I hope that all of this is going to make a lot more sense once you do see a particular example. So here's an example which I have taken up on the introduction to probability. I can put up a link up above there to that introduction. So this is a table where we would have, for instance, not a track runner, but this is going to be a theoretical probability, which we normally would study kind of when you are introducing yourself to probability. So for instance, this number 1 here, okay, this is 1 die, right? So if you roll a die, you know that you can get 1 to 6, and they're kind of all equal probable. And then if we mix this up and make it a little bit more complicated, okay, so here is a second die, okay, so we have now 2 dice, okay, and then again, this is 1 to 6 right here that we would have. And we are interested in, for instance, the sample space, okay? So the entire sample space, so those numbers that you see there, that is just nothing else but the sum when you roll the 2 die together, all right? So if you roll a 1 and a 1, you know that the sum is 2. If you roll a 2 and a 3, all right, you know that the sum is 5. So I've just kind of entered all of these. So we have 36 entries. So my sample space is 36 entries, and it starts from 2. And then there's 2 3s, then there's three fours and 4 5s and so on, as you can see if you're looking at the diagonal. So that's the entire sample space, and for that sample space we know that the total number of them is 36. Now let's take where our event A, all right, so this is going to be defined as, all right, so that's what I defined as. I kind of like to write it like this, but in books, you might actually just see it with a simple equal, and it is a set. So this event A, let's assume that we're going to have the event A, that the sum is going to be, less than and equal to 4, which is something that I have done in a previous video. So for this, if I entered how many times does this actually happen, we can certainly see that right from the entries, because we have done this. So we know that if we roll a 1 and a 1, we're going to get a 2. A 3 and a 3, we see right there if we roll a 2 and a 1. And then, the sum, I guess, is going to stop right here, because everything else is actually going to be bigger than 4, right? So this particular event, that we have, in here, so our entries, I'll just put ... would have been our entries right here, or, you could have written it, as simply what were the two dice that you were rolling. So maybe a 1 and a 1, resulted in a sum of 2, and then you can put the other entries as well to have all of these. I'll put the dots, and then we have 5 entries. So my total n of A is equal to 5. So we would know that the probability of A happening here, just as it's defined, so notice this is the probability, of A, which is equal to the total number of occurrences of A divided by the total number of occurrences within the entire sample space. So within here, this would have been just simply 5 over 36, and that would have been our answer in terms of probabilities. But now what if we wanted to talk about the odds? What are the odds of A happening, of this event happening? So instead of saying probability, which you can write as a fraction like this, or you can write it as a percent if you wanted to, you can convert that. But if you talk about odds, with respect to this event happening, then we're not going to be writing it like this, because the odds are defined as the probability of A, to the probability of not A happening. So if you have this, you would have 5 over 36, which is the probability of A, 2. Now, probability of not A, well, that would be 31 over 36, right? Now, you can write it like this, but we typically don't have, especially if we use kind of this ratio notation. This is redundant, so we don't really write, the entire sample space. And what you would see is, this would just simply be written as 5 to 31 as your actual odds. And if you can reduce this, you will, right? Except 5 doesn't go into 31, 5 is prime. And that's how it would just simply stay. The other way of writing these odds, which you also will see in some textbooks, is going to be like this, where you're just simply writing it as a fraction, which is kind of convenient, because if you ever need to reduce, you can do so. So if I transfer this, into a fraction, which would have been 5 over 36, that's my probability of A, divided by 31 over 36, now you very quickly see why this 36 is going to fall apart. Because if you simplify this, right, then this is just going to be 5 over 36. It's kind of, this is division symbol. So that means I can do the reciprocal as so. And here is your 5 over 31, or written in terms of odds as a ratio, you can write it in that way, all right? And you can choose any event that you like, within here. You can talk about flipping coins, you can talk about cards in terms of poker, so what are all of these different odds of, let's say, getting a royal flush or getting something else? So you can find those odds very quickly if you already know what the probabilities are. So it is useful, and you do sometimes see it, okay? So I think it will help you understand if anyone talks about odds or if you're reading about odds, so how you can convert them back and forth, okay, with respect to probabilities and odds. Now, if someone gives you the odds, so if instead we would have started and someone said, okay, you know, so the odds of event A, in this case, getting a sum of 4 or less, okay, when you roll the 2 die, then what you would have is, these would be the odds. Now, how do you convert this back, okay, into a probability? Well, don't forget that this actually is your probability. So what you would have is, if you wanted to know what the probability of A from the odds you would have, okay, so this would have been 5, right, divided by, now this is the probability of not A. So you're going to have to say 5 plus 31, and this gives you back exactly what you have in terms of probabilities. So you can go back and forth between odds. Now in general, okay, what you have, so if we write any general, so I don't know, let's say A, you know, to B, okay, if now those are the odds, then the probability of A would simply be A all over, and then A plus B, which makes it very simple. If you want the probability of not A, okay, then you take the bottom number from your odds, so that would have been B, okay, all over A plus B. And now you have all of these. And as you know, this plus this, when you add them, will give you 1, okay, which is exactly what you would see here. Because if you add these two fractions, then you're going to get A all over A plus B, B all over A plus B, and clearly this is A plus B all over A plus B, which just equals to 1, as these cancel. So that's how you can work between probabilities and odds. I'm not going to give much more than this. I think, you know, once you see this kind of once, and you start using it a few times, you can go between odds and probabilities rather quickly. All right, thanks for watching. We'll see you in a future video. Bye, everybody.